In the last 3 videos we've been looking at surds. We've looked at simplifying, we've looked at expanding brackets, we've looked at addition and subtraction, and finally we looked at rationalising the denominator of a fraction. In this video we're going to do some really challenging exam style questions and extension questions. Some of these might be beyond the scope of your course. So let's go ahead and look at some of them. The diagram shows a right angle triangle. The length of the base of a triangle is 2 root 3 centimetres. The length of the hypotenuse of a triangle is 6 centimetres. The area of a triangle is a centimetre squared. We need to show that a is equal to k root 2 given the value of k. Let's just draw a quick sketch. So we've got a right angle triangle. I know that the area of a right angle triangle is 1/2 the base multiplied by the height. The problem with this particular triangle is that we don't have the height. We've got the base, which is 2 root 3. We've got the slant height, which is 6. What I want to find now is this length or height, h. I can then say that the area of a triangle is going to be 1/2 base times by height. So that's 1/2 2 root 3 multiplied by h. That will simplify nicely, and we can say that the area is going to be root 3 h, and that will be centimetres squared. So let's go ahead and find h. We can use Pythagoras theorem to find the missing length right here. So this is one of the shorter sides, so we can say that h squared will be equal to the hypotenuse squared minus now the other shorter side squared. If we just look at this quantity 2 root 3 squared, we could either square the 2, which would give us 4, and square the root 3, which would give us 3, or we could look at this as an unsimplified surd. I could actually write that as the root of 12 squared. We know that root a multiplied by root a is going to give us a, so the square root of 12 squared is 12. So you can either square that one 4, square that one 3, and multiply them, or you can see it like so. So what we're going to have is h squared is equal to 36 minus now the 12. So h squared is going to give us 24. We'll take the positive square root, so h will be root 24. At this stage I could go ahead and simplify this root 24. What I'm going to do is just bring back a. The area is root 3 multiplied now by h, which is going to give me the root 24 that I've just found. So with this I've got a few different choices. What I'm going to do is simply multiply the two. We know that root a multiplied by root b gives us root ab. So this is going to give me 3 times 24, which is going to give me 72. I could write this now as 36 times by 2, so root 36 multiplied by root 2, which is going to give me a is 6 root 2. So the area is 6 root 2 centimetres squared, and the value of k is 6. Alternatively, what I could have done is written now that the root of 24 is actually now the root of 2, the root of 4 times by 6, so the root of 6, or I could have written this now as the root of 4 times by the root of 3 times by the root of 2, and substituted it just here. We would have seen that root 3 times by root 3 is 3. This is going to give me 2, and we're simply left now with the root 2. It's entirely up to you. We've looked at different techniques. This would probably be my favourite approach here, but it's entirely up to you on how you want to express that root 24. Final answer though is going to be 6 root 2. So k is 6. In this one it says given the quantity a plus 2 root 3 multiplied by the quantity b minus root 3 is 9 root 3 minus 1, find the values of the integers a and b. So what we've got here is an identity. What I'm going to do is expand the left hand side and then do what we call equate coefficients. So we're going to have terms in root 3, and then we're simply going to have rational values as well. So let's go ahead and do that. We're going to have a multiplied by b, which gives me ab. I'm going to have a multiplied by negative root 3, which is going to give me now the minus a root 3. Then I'm going to have 2 times by b times by root 3, so that's going to be 2b root 3. Then we're going to have 2 times by negative 1. Root 3 times by root 3 is 3. So that's going to give me now negative 6 or minus 6. So let's have a look at this. What I'm going to do is look and say, well, the rational values, we're going to have a, b, and then we're going to have now minus 6. If we look at the right hand side, that must be equal now to negative 1. And I'm going to call that equation 1. So all I've done is looked and said, well, if I collect now these terms that we know that a and b are integers, okay? So we can say that a multiplied by b minus 6 must be equal to minus 1. If we now collect the root 3's, I'm just going to factor this. On the right hand side, we've got root 3. I've got 2b minus a. So 2b minus a. Now we can equate this with, on the right hand side, the 9 lots of root 3. And I'm just going to write it like so. So what we can see from this, and this would be equation 2, from here we could see that equation 1, adding 6 to both sides, ab is equal to 5. If we now look at equation 2, we can say that 2b minus a, so 2b minus a will be equal to 9. We now have simultaneous equations that we need to go ahead and solve. I'm just going to rewrite equation 2, and I'm going to write that equation 2, subtracting 9 from both sides and adding a, 2b minus 9 will be equal to a. I'm now going to substitute that in to equation 1 to eliminate a and get an equation in b. So what I'm going to have is 2b minus 9, that is a, multiplied by b will be equal to 5. We're going to solve this quadratic equation for b, so I need to expand the brackets. 2b squared minus 9b is equal to 5, so subtracting the 5 from both sides, minus 5 is equal to 0. So that's a quadratic, it's in the form that we want, and it looks like I can factor this. So I'm going to have 2b plus 1 multiplied now by b minus 5, and that will be equal to 0. So from here we could see that b would be equal to negative 1/2, or b would be equal to 5. We're told that a and b are integer values, so b must be equal to 5. I can now go ahead and substitute that into any of these equations right here. And if I do that, subbing it into now equation 1, we know that a multiplied by b is 5. So I can say that a multiplied by b, which is 5, must be equal to 5. So we can say from this that a is equal to 1. So we found those integer values. That is one way that you could do that question. So quite a challenging question, but hopefully you can see you're simply now looking at the rational and irrational parts of this and equating the coefficients or matching them up. So another really quite tough question. In this one it says the diagram shows a rectangle measuring 3 root 2 minus 3 centimetres by L centimetres. Given that the area of the rectangle is 6 centimetres squared, find the exact value of L in its simplest form. So what we've got then is the following. We've got 6 centimetres squared. I know that the length times by the width is the area, so we can say that the area is the length multiplied by the width. If I just write this out, and I'm looking already that I could probably factor this, I think with the 3 root 2 minus 3 we could factor this. So the area is 6, and that is going to be equal to the length, which we've got now as L, multiplied by this width right here. So just factoring that, I'm going to write that as 3 root 2 minus 1 multiplied by L. At this stage, I'm going to divide both sides by 3. So what we've got is 2 is going to be equal to root 2 minus 1 multiplied by L. You certainly don't need to do that. I just think it makes it slightly easier. So what we want to do is solve L. So I'm going to divide both sides by the content of this bracket, which is the root 2 minus 1. So that is going to give us L. We need to give this in its simplest form. So at this stage, we need to rationalise the denominator of this fraction. As we've seen before, we multiply the numerator and the denominator by the same values in the denominator, but we switch the signs. So we multiply by what's called the conjugate, or if you like, we create the difference of two squares. So we have root 2 minus 1 multiplied by root 2 plus 1. I'm not going to expand the numerator, I'm simply going to expand the denominator. So I've got now 2 lots of root 2 plus 1. I'm going to have now root 2 times by root 2 gives us 2. We're going to have plus root 2. We're going to subtract root 2. And finally we're going to have now minus 1. So we can see from this now that in the denominator we cancel these two. This is going to give me 2 minus 1, which is 1. So we can write this as 2 lots of root 2 plus 1 over 1. Therefore, I can simply write now that this will be 2, then we're going to have root 2 plus 1, which is equal to L. I'm going to leave it like that rather than writing it now as 2 root 2 plus 2, and that is in its simplest form. You didn't have to divide by the 3, you could have gone ahead and expanded it out. Either way round, in its simplest form, this is what we should get. So another quite tough question. Given that the point with coordinates 1 plus root 3, 5 root 3 lies on the curve with equation y is equal to 2x squared plus px plus q, find the values of the rational constants p and q. So this is our equation, and we can substitute in the values. This is the y coordinate, this is the x coordinate. So all I'm going to do is to write 5 root 3 will be equal to 2 lots of the x coordinate, which is 1 plus root 3, plus p lots of the x coordinate, which is 1 plus root 3, and then we're going to have plus q. I'm going to, let's just square that, I need to square that bracket. I'm going to square the bracket, and then, like I did in the question before the last one, I'm going to equate the coefficients. So we got 5 root 3 will be 2 lots. If I expand this, I'm going to get 1 plus root 3, which is going to give me plus 2 root 3. And then root 3 times by root 3 is just going to give me 3. I'm then going to expand this bracket, and I'm going to get plus p multiplied by the root of 3 plus q. If I now just collect the 1 and the 3, that gives me 4, and then expand the brackets. 1 plus 3 is 4, 2 times by 4 is 8, plus now the 4 root 3, and then we're going to have plus p, then we're going to have plus p root 3 plus q. Therefore, what I can say, if I just consider equating the rational and irrational parts, I can see from here that 5 root 3 will be equal to 4 root 3 plus p root 3. So that tells me now that if I divide, well, I could subtract the 4 root 3 if you like, or just divide through first by root 3. 5 will be equal to 4 plus p. So we can see from this now that p will be equal to 1. So from there I can see that p is equal to 1. If I now look at the rational parts, on the left hand side we've got 0. On the right hand side we've got 8 plus the p plus the q. We already know the value of p, so we can say 0 is equal to 8 plus the 1 plus the q. So we've got 0 is equal to 9 plus q, so subtracting 9 from both sides, q will be equal to negative 9. And we've gone ahead and solved. I've just simply expanded the brackets and we've equated the terms. So again, quite a nice question, but quite involved. And again, it may be beyond the scope of your course. In triangle ABC, AB is 2 root 3 minus 1, BC is root 3 plus 2, and angle ABC is 90 degrees. So we've got a right angle triangle. We're asked to find the exact area of a triangle ABC in its simplest form. So we know that it's 1/2 base times height. So the area is going to be 1/2. We've got the base, which is going to be the root 3 plus 2 multiplied by the perpendicular height. So on this one, we do have the perpendicular height. Check with your exam board exactly how much working they expect. What I'm going to do is simply write that this is 1/2. If I multiply root 3 by 2 root 3, I'm going to get 2 lots of 3. We've seen before that the root of 3 times by the root of 3 is 3, and then we're going to have now multiplied by 2. If you want to write that straight as 6, do check that that's acceptable with your exam board. Root 3 times by -1, we're going to have minus root 3. Then we're going to have plus 4 root 3. And finally, we're going to have 2 and 1. We've got a negative and positive, so it's going to be minus 2. So we've got now, if I tidy this up, 1/2. We've got 6. We've got plus now 3 lots of root 3 minus the 2. And I can write this now as 1/2. You don't need to do all these steps. 1/2, and then we're going to have on here plus 3 root 3. So we can write that this is going to be 2 plus 3 over 2 root 3. So that's one way it can be written, and that will be units squared. So square units or unit squared. So that's one way that you could do that question. So that bit's answered. We need to show that AC is 2 root 5. It's a right angle triangle, so we can use Pythagoras. So what I can say then is AC squared, and of course you can call that y or x if you like, will be equal to 2 root 3 minus 1 squared plus root 3 plus 2 all squared. So all we're doing is Pythagoras. 2 shorter sides squared added together is equal to the hypotenuse squared. So from this, expanding the brackets, if I multiply this out, 2 root 3 multiplied by 2 root 3 is going to end up giving me now 4 times by 3. 2 times by 2 is 2, 2 times by 2 is 4, root 3 times by root 3 is going to give us 3. Then we're going to have now minus 2 root 3 minus another 2 root 3, which is minus 4 root 3. Then we're going to have on here plus 1. So plus 1. Then expanding this bracket, we're going to have root 3 times by root 3, which is 3, plus 2 root 3, plus another 2 root 3, which is going to give me plus 4 root 3. And then finally, we're going to end up with plus 4. If we look at this now, we can see quite conveniently the 4 root 3's cancel. So we've got AC squared will be 12 plus the 1 plus the 3 plus the 4. So AC squared is going to give us 20. I can now take the square root, and we've got the positive square root. AC is going to be the root of 20, and we can say that AC is going to be the root, simplifying this, the root of 4 multiplied by the root of 5. So AC will be equal to 2 root 5 as required. So all I've done is use Pythagoras and used my Surds rules. Okay, let's move on and look at the next one. We need to show that the tan of the angle ACB is equal to 5 root 3 minus 8. If we look at this angle, ACB is this one just here. So that's ACB. So relative to this angle, we can say that this one is the opposite and this one is the adjacent. The tan of the angle, so we can say tan of ACB will be equal to the opposite over the adjacent. So let's go ahead and do that. So I can write this now as 2 root 3 minus 1 over the adjacent of root 3 plus 2. As you can see, we need to write it in this form, which means I need to rationalise the denominator of this fraction, which is going to give me root 3 minus 2. We're going to be multiplying the numerator and the denominator by the same numeric values, but with different signs. So root 3 minus 2. I'm going to expand the numerator, so I'm going to have 2 root 3 multiplied by root 3, which is going to give me 2 lots of 3. I'm then going to have minus 4 root 3. I'm going to have minus 1 root 3. And then I'm going to have plus 2. That now will be over the denominator, and we've got a denominator, root 3 times by root 3 is going to give me 3. then we'll have minus 2 root 3, we will have plus the 2 root 3, and finally we will have now minus 4. So minus 4. We know that these are going to cancel. We've seen this time and time again. So in the numerator, we're going to have 6, and I'll just write this out step by step. 6 minus 5 root 3 plus the 2, and in the denominator, we're going to have minus 1. So we could write this simply now, I'll tidy the numerator one more time. What we can write is that will be minus 5 root 3 plus 8 over now minus 1. So simply multiplying through by the negative 1, and I'll just put it here, multiplied by negative 1. Therefore, what we've got here is 5 root 3, and then we're going to have minus 8 as required. So again, a really quite tough question. If you can understand that the tan of the angle is the opposite over the adjacent, and you can rationalise, it becomes quite routine, but it's spotting that. So there we go, a few really quite challenging, nice questions looking at using surds. As stated, these might be beyond the scope of the course that you're doing.